So basically, we are going to learn how to use the GIS softwares. GIS stands for the Geographic Information System. That's the geographic is the location, the information is the attribute, and then the system is a tie from the information to the geographic location in a seamless operation. What do you mean by GIS? GIS is a system used to create, manage, visualize, and analyze spatial data. And then in GIS, you have component of this software, which is the hardware, the software, the people, data, and then procedures. And there are some few terms in GIS. That's the spatial data. The spatial data is the data that can be linked in geographic spaces to some features on a map that has both a spatial and an attribute component. So we are going to talk about attribute. Attribute is a characteristic of a feature that contains a measurement or value for the feature in a column in a data file. Feature. Feature is a term used to represent real-world features in a digital format. Feature is a term used to represent real-world features in a digital format. And then, now, the GIS software and then a hardware. A software that performs part of the GIS is called GIS application. So, GIS software are resource intensive, hence requires better computer requirement for smooth running. In general, the bigger and then the faster, the better. A physical machine needs to meet a minimum requirement to run the GIS software. There are two types of GIS software. That's the commercial and then a freeware. The examples of the commercial GIS software is the ArcGIS, ArcGIS Pro, EDAS Imaging, MV, MapInfo, Global Mapper, or Safer. And then examples for the freeware GIS software are the QGIS, Eloise, Grass GIS, and then Google Earth Engine. These are the examples of the GIS software. About the GIS data. The GIS data is how to map the real world. And then there are two types of GIS data. That's a vector and a raster. A vector data is generally used to represent discrete data. That's buildings, geology. Vectors stores GIS data by three distinct geometric primitives. That's points, polylines, and then polygons. It is mostly for discrete data. A point is composed of one coordinate. A point is composed of one coordinate pair, x and then y, for a single location. In a coordinate system, it's dimensionless. That's no length or area. Examples: wells, towns, outcrop locations. These has no length or area. So a polyline is two or more coordinate pairs called vertices. This one, it has length but no area. An example of a polyline are roads, rivers, traverses, etc. Also, a polyline has three or more line segments whose starting and ending coordinate pairs are the same to store data. It has both and area. Example of this polygon is boundary, catchment, geology. Vector data format in GIS application. For the vector data format in GIS applications, we have these files or these formats that help us to store data in the QGIS. that helps us to store vector data in the QGIS application. We have the shape file, we have the geodatabase, and then the geo package. The shape files, it has a format of .shp. Then the geodatabase has a format of .gdb, and then the geo package has a format of .jpkg. That's the format file, or the format installing or saving a vector data in GIS application. The shape file is one of the oldest and most widely used methods for storing vector data. The shape file keeps the geometric shapes, that's the point, the polylines, and then the polygons. Also, the attribute of geographic objects together. Alright, the shape files also consist of at least 3 files. That's the .shp, that's the geometry, .dbf, the attribute, and .shx, that's the index files. The geometry or the map are the geographically representation, that's the shape of data on the map. Attributes or table, which are the information that are being stored about the data. So we talk about the geodatabase. It stores multiple features, classes, tables, and rasters in a single container. This is commonly created by ESRI. That is commonly used in the GIS application. That's the ArcGIS and then the ArcGIS Pro. It allows users to manage everything in one location. We talk about the another file, or the other format of a vector data in GIS. That's the geo package. The geo package functions similar to the geodatabase, but this is commonly used in QGIS. We are going to talk about the other GIS data. That's the raster data. The raster data is a cell-based containing coordinates, information, and values for each cell. Thus, each cell values can contain information such as the elevation, the slope, rainfall, or any other surface value spread across the geographic region. The raster cell values can be either integer or floating point, that's raw. In GIS application, the values in each grid cell can be counted. It is well be stored in attribute form as value and count, used to represent continuous data on Earth. Example is the elevation, the temperature, and then water level, that's etc. The raster data they are also stored in a GIS application in a format of GeoTIFF format. This GeoTIFF format contains a header that specifies the spatial reference system, coverage, and other metadata about the data. The GeoTIFF is widely supported by the GIS software and is interactive with other spatial data formats. There are a lot of formats that can be where the raster data can be stored in. We have the EDAS image format, the NetCDF format, the HDF format, the cloud-based storage, and the multi-resolution raster. There are a lot. They all stores, or they all saves raster data. So in this video, we just talk about the application of this software that we have been using. That's the GIS. But basically, in our subsequent videos to come, we are going to use the software, which is the QGIS, to do these things that I've said. The QGIS is our main software for this program. Thank you all, and let's meet for our next video.